Hello everyone, and welcome. Today, we're going to explore the exciting world of advanced materials and talk about something called polymer nanocomposites. It might sound like a complicated term from a science fiction movie, but the concept is straightforward and is already changing the world around us. Let's start with the basics. First, what is a polymer? A polymer is just a scientific name for many common materials we call plastics. Think of a plastic bottle, a nylon jacket, or the dashboard of a car. These are all made of polymers, which consist of very long chains of molecules, almost like a massive tangle of spaghetti strands. Now, let's look at the nano part. The term nano refers to nanoparticles, which are incredibly tiny particles. How tiny? A nanometer is 1/1,000,000th of a meter. To put that in perspective, a single sheet of paper is about 100,000 nanometers thick. So these particles are microscopic, far too small to see with the naked eye. Examples of these nanoparticles include tiny tubes of carbon called carbon nanotubes, flakes of clay, or tiny spheres of metal oxides. So, a polymer nanocomposite is what you get when you mix these two things together. You take a regular polymer, which we call the matrix, and you add a very small amount of these nanoparticles, which act as a filler. The amazing part is that you only need to add a tiny fraction, often less than 5% by weight, of these nanoparticles to completely transform the properties of the original plastic. This is where the real magic happens. By adding these tiny particles, we can create materials with incredible new abilities. For example, 1. Enhanced strength and stiffness. The nanocomposite can become much stronger and more durable than the original plastic, but without adding significant weight. This is why they are used in high-performance sports equipment, like tennis rackets and bicycle frames, and in the automotive and aerospace industries to make lighter, more fuel-efficient vehicles. 2. Improved barrier properties. They can be much better at blocking gases like oxygen from passing through. This is fantastic for food packaging, as it can help create plastic bottles and films that keep food and drinks fresh for much longer. 3. Increased thermal and fire resistance. The new material can often withstand higher temperatures and be more resistant to catching fire, making it safer for use in electronics and construction. 4. Electrical conductivity. Most plastics are insulators, meaning they don't conduct electricity. But by adding conductive nanoparticles like carbon nanotubes, we can turn an insulating plastic into a material that can conduct electricity, which is useful for things like anti-static packaging for sensitive electronic components. Essentially, polymer nanocomposites are superplastics, engineered at the nanoscale to be better in almost every way. Thank you so much for watching. If you found this video helpful and learned something new, please give it a thumbs up and consider subscribing to support the channel. It really helps us create more content like this for you. We'll see you in the next one.